The greenhouse effect is one of the main technogenic problems of mankind. An increasing amount of carbon dioxide is released into the atmosphere. At the same time, one of the significant sources of carbon dioxide emissions is the production of cement. In the production of cement, 90% of emissions occur during the manufacture of clinker. Therefore, reducing the proportion of clinker in a cement can reduce emissions by more than 60%. One way to reduce the proportion of clinker in cement is to reduce active mineral additives into its composition. For example, granulated blast furnace slags. But exceeding the maximum allowable proportion of additives leads to a deterioration in the characteristics of cements. A further reduction in the proportion of clinker in cement is possible using various activation methods. Our group is investigating the possibility of using magnetic spin effects to activate blast furnace cement. The effects themselves have been well studied. Their essence lies in the fact that magnetic fields affect the spin dynamics and control the spin multiplicity of radical pairs of substances involved in a chemical reaction. The problem was how to ensure a long-term effect of magnetic fields on the process of cement hydration, from the moment of mixing with water to long periods of hardening. We solved this problem by introducing a finely dispersed ferromagnetic magnetized substance into the composition of Portland slag cement. To reduce costs, it is proposed to use dusty waste from the metallurgical industry as such a substance. In our previous work, it was shown that the magnetic fields created by the dust additive can have a positive effect on the activity of cements. At the same time, it was revealed that the strengths of characteristics of Portland slag cement are affected by both the magnetization of the particles and the disperse composition. The effect of additive on the mechanism of hardening of the cement components and the structure of the cement stone was studied. In the process of research, nonlinear dependencies of the activation effect created by the additive on the technological parameters of cement hardening were revealed. Therefore, in the current study, we set the task to identify how the activity of the binder is affected by method and duration of mixing the additive with the binder, share of a slag in a cement, and temperature of hardening of cements. The existing technology for cement production allows mixing the binder components either with the creation of tribochemical processes or without them. In the first case, mixing is carried out in ball mills. In the second, using mechanical mixers or air mixers. Mixing components in a ball mill can be combined with grinding of clinker, gypsum, and BFAS or carried out after that. Therefore, the three series of experiments were compressed in the research. First one, clinker, BFAS, and gypsum were mixed into a laboratory ball mill. The mill was filled with MFDA at the amount of 2% by the weight of binder components. Next, joint grinding was carried out. Finally, an MFDA free control binder was prepared similarly. Second one, a ready-made BFAS and MFDA were placed in a laboratory ball mill. In different experiment series, dust and cement were mixed from half to 16 minutes. Simultaneously, additional mixing of the control samples was carried out without an MFDA. And the third one, the MFDA was introduced into the BFC and mixed in a specially designed device for from half to 16 minutes. Mixing the MFDA with a blinder by the first way does not create, and the third way creates a weak activation effect. However, when mixing the components according to the second method with an increase in the mixing time, the activation effect first increases and then decreases again. The revealed regularities show that the magnetic fields induced by the dust effect, the tribochemical phenomena occurring during cement grinding. With excessive grinding time, the size of dust particles decreases and causes them to heat up. This leads to an activation effect decrease after a specific time of MFDA joint grinding with cement. Thus, long-term grinding completely neutralizes the impact of MFDA. According to the results of the experiments, the optimal time from grinding the MFDA with cement is 5 to 10 minutes. Studies of the strength characteristics of binders with different BFC and MFDA ratios were carried out to identify the optimal amount of MFDA in cement with different BFS content. Investigated binders having in their composition in various series from 0 to 2.5% of MFDA and from 0 to 80% of BFS. The results show that with an increase in the proportion of BFS, the need for MFDA increases, and the activation effect enlarges. At the same time, an increase in the amount of MFDA added to BFS free cement causes a drop in the activity of binder. The reasons for this regularity were studied by us and described in a previous work. The obtained data show that introducing an MFDA into the composition of the BFC makes it possible to obtain cement of equal strength with an increased BFS content against the usual range. The resulting decrease in the share of clinker makes it possible to significantly reduce the consumption of fossil fuels and emissions associated with cement production. The next technological parameter that we studied were the modes of hardening of BFS with MFDA. Studies of strength characteristics of cement steamed at different temperatures with different amounts of the added MFDA were carried out to clarify the optional hardening regimes. The steam curing was carried out of temperatures 50, 80, and 90 degrees. Samples have tested 24 hours, 28 days, and 3 months after steaming. The obtained data shows that with an increase in the amount of MFDA in the binder, a more significant increase in strength is observed at lower temperatures. Thus, the combined action of the MFDA and temperature increases the destructive process occurring during clinker hydration and, simultaneously, intensifies the process of binding hydrated lime and slag hardening. The research results show that the most significant increase in strength has been observed in samples steamed at 70 degrees. The recommended steam curing temperature for ordinary BFC is 90-95 degrees. The introduction of MFDA into the composition of the BFC makes it possible to reduce the steam curing temperature of products by 20-25 degrees. Thus, the introduction of MFDA makes it possible to save energy resources of heat treatment, prefabricated, reinforced concrete significantly. Thus, the impact of the magnetic spin effects during the production and hydration of cements by introducing additive we proposed into the composition of cements is one of the possible ways to reduce carbon dioxide emissions into the atmosphere and improve the climate on the planet. Thank you for your attention.